Okay, so let's imagine our planet is going in for a health check. To do that, we're going to look at two of the most important climate reports out there. First, you've got the IPCC report. Think of that as the doctor's diagnosis. It's the part that tells us, here's what's wrong. And then we'll look at the IEA report. That's the prescription, the detailed treatment plan for how we get our planet back on a healthy track. Let's dive in.
So here's our game plan. First up, the diagnosis. What exactly is the science telling us is happening right now? Then we'll get into the prognosis. What are the risks we're looking at if we just, do nothing? But we're not going to leave it there. We're going to explore a real roadmap to recovery, the big ideas behind that plan, what it's all going to cost, and finally, what part we all play in making this happen.
All right, let's get right into that diagnosis. For this, we're turning to the IPCC. You can think of them as the world's leading specialists, thousands of scientists who've put together the most complete physical exam of our planet's climate you can possibly get. And the number one symptom? Our planet has a fever, a pretty significant one. The global surface temperature is already up by 1.09 degrees Celsius compared to pre-industrial times. And here's the thing, scientists are stating this with high confidence. This isn't a hunch or a guess, it's a measured fact. Our planet is hotter right now than it has been in the last 2,000 years. But that number, 1.09 degrees, it's not just some abstract data point on a chart. It has a real and frankly a devastating human cost. As this quote right from the IPCC report shows, the impacts are not spread out evenly. For the billions of people living in the most vulnerable parts of the world, this isn't a future problem. The consequences are already here and they're catastrophic. So the next logical question is, what's causing this fever? Well, the science is completely settled on this. The IPCC's best estimate is that of that 1.09 degree fever, 1.07 degrees of it is because of human activity. The big takeaway here, when you look at that fever, pretty much all of it is us. Okay, so if it's us, where are these emissions actually coming from? This chart makes it painfully clear. A massive 78%, the lion's share, comes from the very engines of our modern world, how we create energy, run our industries, get around, and construct our buildings. This tells us right away that to treat the fever, we have to fundamentally rethink the systems that power our everyday lives. So, with that diagnosis in hand, what's the prognosis? What happens if this fever just keeps on climbing? Now, this is one of the most sobering findings in the entire report, because these greenhouse gases hang around in the atmosphere for a very long time. We're already locked into more warming no matter what we do today. The IPCC now says that it is more likely than not that we will cross that critical 1.5 degree threshold by 2040. The clock is absolutely ticking. And the danger here doesn't just go up in a nice straight line. It escalates, and it escalates dramatically with every single fraction of a degree. At 1.5 degrees, we're staring down the barrel of losing over 70% of our planet's coral reefs. Push past that, and extreme weather gets much, much worse. And then you have these large-scale tipping points, things like an ice sheet collapsing, which could trigger a domino effect of irreversible changes across the entire globe. And we just have to be totally clear-eyed about this. Some of these changes are already baked in. Because our deep oceans have soaked up so much heat and our ice sheets are already melting, a certain amount of sea level rise is now locked in for centuries, maybe even millennia. We can still control how much and how fast it rises, but we can no longer stop it completely. And just to really hammer home what is at stake here, look at this quote. If we let the world warm up and stay between 2 and 3 degrees, we are basically committing future generations to the almost complete and irreversible loss of the Greenland and West Antarctic ice sheets. We're talking about meters of sea level rise. That is the long-term legacy we are currently on track to leave behind. Okay, that prognosis is incredibly grim. But remember, the diagnosis also gave us a huge clue. That's 78% of emissions coming from our energy system. So for the prescription, we're going to turn to the International Energy Agency, or the IEA. They've put together an incredibly detailed roadmap for how the global energy sector can get to net zero emissions by 2050. The IEA's plan isn't vague, it's a series of really ambitious milestones. And it starts right now, today, with a call for no new oil and gas fields. By 2030, the pace just explodes. And by 2040, the entire global electricity grid has to be net zero. This timeline just shows you the incredible scale and, maybe more importantly, the speed of the change that's needed. So the big question is, how on earth do we even begin to achieve this? Well, the IEA breaks this monumental challenge down into a few core strategies. These are the four big pillars of the plan. First up, efficiency. Just getting a whole lot smarter about how we use energy. Second, electrify everything. That means switching our cars, our heating, and our industries over to running on electricity. Third, clean the grid. We have to make absolutely sure that all that new electricity is coming from clean sources, like solar and wind. And fourth, innovate. For the really tough stuff like aviation and heavy industry, we're going to need brand new solutions like clean hydrogen and carbon capture. Now this is a really fascinating point that reveals both a huge challenge and a massive opportunity. The IEA is very clear. We can't get to net zero with just the technology we have today. Nearly half of the emissions cuts we need by 2050 will have to come from technologies that are still in development right now. This is basically a giant call to action for a coordinated global push in innovation, and it has to start immediately.
Of course, a transformation this big, this fast, it comes with a pretty hefty price tag. So let's be real and talk about the cost of action.
And, well, it is a staggering number. The IEA estimates that we need to more than double our annual global investment in energy from about $2 trillion today to almost $5 trillion by 2030. This would be one of the largest mobilizations of capital in human history, fundamentally shifting money away from fossil fuels and pouring it into clean energy. But here is the absolutely crucial point. According to the IPCC's own economic analysis, while the price of action is high, the price of inaction is far, far higher. Yes, the investments are enormous, but the economic benefits from avoiding the worst climate damages, not to mention the co-benefits like cleaner air, actually outweigh the costs of doing all this. It's an investment, not just a cost. And it's so important to see that the payback here isn't just about the climate. This path leads to a healthier world with cleaner air for our kids to breathe. It sparks innovation, it creates brand new industries, and it improves our energy and food security. So this isn't just about dodging a disaster. It's about actively building a better, more prosperous future. Finally, none of this can be done by any single group acting alone. This is going to require a truly collective effort from everyone, all pulling in the same direction. It's really easy to feel like this is all on our individual shoulders, but the IEA's analysis shows something really interesting. While our personal choices definitely matter, a whopping 75% of the emissions cuts that come from behavior changes depend on government policy. Think about things like better building codes, fuel efficiency standards, or big investments in public transit. Those are the things that create the framework that allows all of us to make better, cleaner choices. Policy sets the rules of the game. So there we have it. The science has given us a clear, urgent diagnosis of a planet with a dangerous fever. And the energy experts have written a detailed and, yes, very challenging prescription for a net zero recovery. The question that's left for all of us, for our governments, for our industries, and for us as citizens, is the most important one of all. Will we follow it?